on the attendance sheet. I wouldn't like to do that, but what to do? Yeah. So I'm assuming you can see me, right? And because I'm not seeing my picture here, I don't know why this time around I'm not seeing the picture. Right? I'm seeing all this Farah Nabila, Muhammad Nur Hafizi. I'm seeing Nur Izzah Sarah telling me yes, okay. Razin is here. Dengar kata dia. Alright. Okay, look. But Arman and Shakila told me that then my laptop in the study, but I wasn't too sure but confirmed that I could be able to do that. So it does appear as well. What I would like to do today, right, is just to see whether this LN stick, all right. Then when or this communication is okay. So if this is acceptable in the sense that I have an option, if you recall the last time when I was just on the Wi-Fi, right, using the Wi-Fi alone, when I stick this wireless adapter, then last time when I wasn't able to maintain the weather and sustain with you, right, using the Yeah. You can see me too, yeah. So I think I have to auto rotate and all of that, right? So I think where's the auto rotate? Okay. Right. There is now 49 people. Fazli says hello. Okay. All right. Now I'm on auto rotate, right? Why can't I see the ni? Yeah, Akmal. Okay, Akmal Arman say yes. All right. Okay. Now I am assuming that this is going to be our our method of learning and teaching. I mean, I don't think it is possible to depend on the Wi-Fi. But then again, I did not stick the dongle, right? Maybe if I just stick the dongle, it would be better. But I think for now that the
I think the stability of the Wi-Fi internet right at where I am is questionable. All right, I don't think it's pretty stable. But then again, I don't know. Like I'm using the phone now, right? And I'm using the Wi-Fi of the home Wi-Fi. So you know, last week after Arman's proposal, I was also talking to Shakila, and Shakila said try YouTube or something. So I was watching a concert using the Wi-Fi for about an hour, and it was stable. So I don't know, guys. All right, but if anything, this is possibly the best way. Yeah, this is possibly the best way that we can just go on with our class. So right now, I should have. Can you see this? I should have my this lecture notes. All right. Okay. By the way, I don't have this. I don't have the message anymore from you guys. When I auto rotate, this damn thing goes away. Where is it now? Okay, right. Sasha and everything here down here. Sure. These are all the people. That's not what I want. Here are the 7 messages now it appear. Okay, now I'm getting good at this. Abby says yes. Liana says yes. Sasha says, you're doing great, sir. Thank you very much. Okay, Muhammad Nur Hafizi. Okay, right here. I should have this lecture, right? This lecture notes in front of me. All right. I'm going to talk about from page 3 today, page 3, and I should be able to finish. All right. Only up to page. I plan only to finish up to page 7 with the example. All right. Anything more than that is being ambitious. So I don't think I want to be that ambitious. We'll take it a little bit slow as we go along. Okay. All right. And on top of that, you should also have this foundation engineering notes beside you. All right. This set of notes has bearing capacity and settlement in it, all in one chapter. Right. It's chapter 14. So that's why your homework will include bearing capacity homework and also your settlement homework in this set of notes. All right. So prior to that, having said that, that's what I want to do today. I have also before I forget, right? I have also circulated via Shasha, uh, not Shasha, via Shakila, the whatever I have in relation to online assessment. All right. So it appears, guys, from the last time I spoke to you that the final exam uh, is going to be online. As also, I think Shakila has circulated to you, I hope, right? Maybe she hasn't. She has circulated. She'll be circulating to you after class today. But the final exam is going to be online, and but the SOP, the standard operating procedure for that is not finalized yet. I also sent a PDF file which Dr. Nabila has sent to us regarding general guidelines on online learning and online assessment. I haven't managed to read that. As I was saying to Shakila, I'm just I'm struggling with this, right? And I don't know much what else to say. So if we can move on, all right, on page 3. Now, the reason why we are, I'm going to take it from last week, right? Not last week, last Friday that when I had class with you, right? Now, you notice that the topic on page 3, right, is Campton-Barry method of settlement analysis. And last Friday, what happened was that I talked about what settlement is, and I talk about the definition or the classification of settlement analysis. Right? You have that initial settlement, primary settlement, and secondary settlement. And I did mention to you then that these are all the arbitrary classification that in real life, I mentioned to you that they can all occur at the same time, right? Now, and then I sort of digress from the main set of notes, right? It's supposed then to, I'm supposed to go straight to page 3, but what happened was that we digressed to page 2A, 2B, 2C, and 2D, because 2A, 2B, 2C, and 2D is, some of you may not have the idea of what consolidation is all about, and that was why the digression was there. And then I did mention to you that as we went along to the class, right, into A, 2B, 2C, and 2D, and then we did an example before that, right? We did an example and we said to ourselves that the 4-meter clay, right, is undergoing a consolidation settlement, and then the question to you then is how to get the stresses, right, at the center or in the middle of that thickness of clay, right? You have clay here, and because the top part and the bottom part, so you take the average in the middle, all right? That's the depth of the stresses. So you apply the stresses to as the picture was showing to you, right? The example, you apply 125 kilopascal, and then what, how is this 125 kilopascal being distributed in this footing, which is a rough footing, is you have 15 meters by 30 meters by 45 meters footing, and then the settlement obviously is going to occur in the center, all right, occur in the center. So you split the rough footing, okay, into 4 equal spaces. That's why the word 4 is there in the example, all right, 4 equal spaces. And you use Fadum's chart, all right, use Fadum's chart. Now the problem is how to use that Fadum's chart. Now, following from your soil mechanics 1, where I was giving the lectures to you and teaching you, and I'm somewhat worried because some of you will learn to memorize. You will always look at this example and you say, since there is 4 there, I'll just use 4. Well, no. And I alluded to you to the earlier examples in Craig, and I also showed to you that there is a homework in this set of notes where the areas are not going to be equal. All right. So if you are one of those people who keeps waiting, right, you like to wait, all right, and then when I give you the homework, then then only you start struggling with it, then it becomes difficult for you. So the reason why I just don't give you the homework in advance, like when I finished last week, all right, on the topic of settlement, is because I would like you to spend the time to review what I have said and to go through those classes. Otherwise, it becomes very difficult for you, as I am seeing it, all right, as I notice that you like to wait. So please don't do that. Now, going back to my classes, all right, so when I stop there, right, after the example, and on page 2D, I think, right, on page 2D, you notice at the bottom here, right, at the bottom here on page 2D, I mentioned to you that using that one-dimensional method, the odometer method, all right, now these words you've got to like put it into your head. Odometer equal to conventional method, okay, or sometimes they call it one-dimensional method. They are the same thing. Okay, so sometimes I forget to keep consistent in relation to the words that I use, but you must put it into your head. One-dimensional method equals odometer method equals, all right, conventional method, all right. That's the basis of you learning from soil mechanics. In other words, right, soil mechanics, two in particular where you did the lab. The odometer test, you take a sample, you put it, it's about 50 millimeter diameter and about this thick. If you have forgotten about it, you can look it up in the soil mechanics book, the great book. All right. Now, anyway, if you use that method, and we went to this Waterloo Bridge in London, all right, this Waterloo Bridge in London, and I mentioned to you about the observed settlement, and you would go and take readings every day using a theodolite perhaps, and then for the 20 years or 30 years. Now, if you have that figure, right? There is another figure in relation to this. There is figure 14.1. It's a similar figure, right? But on a different bridge. I didn't bother to inform you about that because I would expect that you would read it. Now you notice the settlement, all right? Conventional is the one-dimensional, is the odometer method. It would predict, right? Some 20 years after the bridge has been built, if you like, end of construction, all right? You notice that the settlement is about 50 millimeter, all right? And then if you notice there on the same figure, 14.2, there is that method called Scanton-Barron, okay? And that would be better predicting at the settlement that's about 60 millimeter. But, even though the Scanton-Barron method is better than the conventional or one-dimensional method or the odometer method, is still, quite far away from the observed value, right? But anyway, in soils, in geotechnical engineering, the factor of safety is high. If you get something better than, say, the other method, the conventional method, all right, you would tend to use it. Now, that's where I stop. Now, why am I reminding you about this? It's because, right, like the bearing capacity, whereby you have several different methods and you cannot just learn one method, all right? Because different situations dictate different things to you. Plus the fact that when, say, you do a site investigation, you also do not have some of this data, so certain data are available, so you can only use that method. So by now, you probably also realize that if you want to do a site investigation, you must know what you want to measure. In other words, what must be in your head to do the analysis, right? What is appropriate for the situation. Otherwise, you would do all sorts of things, right? Just to get the data. Now, this is the reason now I'm going back to page 3, Scanton-Barron method, because you've already known about the one-dimensional method. Now we need to know about that Scanton-Barron method, which is on the figure on figure 14.2. Now, this Scanton-Barron method, okay, is also you will find later, right, when I finish with this topic, you'll find later that they they would try to relate to the one-dimensional method. The charts and the curve and the figures are related to the one-dimensional method. Now, why is that the case? It's because the one-dimensional method, the odometer method, is a conventional method. Everybody knows about it. All right, everybody knows about it. Okay, so that's the reason why you will is there something wrong? I'm not is there something wrong, guys? Do you want to say something? You just send a message to me? No, okay, fine, all right. All right, so okay, there's somebody. Abby is trying to talk, I don't know. Abby, are you okay? All right, now your phone probably is mute now. All right, okay. All right. Okay. Now back to this page 3. All right. So Scanton-Barron method of settlement analysis, the equation from one-dimensional for final settlement. is rho final is equal to rho odometer is equal to m sub e delta sigma 1 times delta z. That's equation 1. All right, that's equation 1. Now, when we were measuring our settlement, all right, using the odometer, that was what we said. All right, we derived that whole equation. We said that this volume of compressibility for the whole thickness, and on the assumption that if at each of the thickness of the clay, the m sub d value is all the same, consistent. All right, with that, then we can use that equation as shown there on equation 1. All right, then the issue was, then we said a few minutes ago, I said to you that the issue is to find the increase in stress, because the stress would give us the strain. All right, strain in our language is just called settlement. All right, so by now the second sentence, right, which says to you that a better estimate of the final settlement would be due to the immediate settlement, the consolidation settlement, and also, on that's equation 2, right? Immediate settlement and consolidation settlement. Now, I did not include the secondary settlement. If you see on that page 2.1, right? This last Friday, sorry, we defined the immediate settlement, and we also defined the consolidation settlement and the secondary settlement, right? So equation 2 anyway is immediate and consolidation settlement. Immediate is the elasticity. The moment you apply a load to any material, doesn't matter whether it's clay, sand, or steel, or concrete, right, or wood, right, you will get some movement, or rather some compression, right, because you apply the load. All right, so that immediate settlement, the easy way to understand it is like elastic settlement. And consolidation settlement, right, equation 2, is just because of the pores, all right, the voids in this material we call clay, all right, are all filled with water. All right, it can be partially saturated, but most of the time when we analyze clay, we say to ourselves if it is fully saturated or it's not fully saturated. And if it is fully saturated, it is all filled with air. It is all filled with pore water pressure. And then the moment we apply a load, all right, we apply a load, any buildings, for example, when we apply the load, it is transferred to the solid first, and then finally it's transferred to the water, right, to the water in the pores, in the voids, right? Okay. Now the solids, the water, right? When you give a fluid, whether it's water or if it is air, right? It increases in pressure. It's like you having a soccer ball. Okay, I'm trying to remind you again about consultation here. The soccer ball, if you put it on the floor and then initially you have within that soccer ball, all right, the football, right? It's like it's all filled with air. It has some pressure, right? Okay, now you sit on it. Put your butt or your ass, if you like, on top of the ball, the soccer ball. Now the initial air pressure plus your weight, which is now being transferred to the air, right? There is an increase, right? An increase in the air pressure. It's the same now with respect to pore water pressure. All right. Initially, it has some static value. All right. Some static value where the water table is. You know how to calculate that. All right. And then you put a building on it. So obviously now the load is being transferred to the solid grains, the minerals, the mineral particles. All right. The particles of your soil. Then it is transferred to the soil. To the water. All right. So now there is excess pore water pressure. Now, why am I taking a bit of time to remind you about this? All right, that situation where the increase of pore water pressure, if there is no dissipation of that excess pore water pressure, right, that is called the undrained situation. Reminding you again, when the pore water pressure is being released, we use the word dissipated, and it is dissipated through drainage, right? Through drainage, then we will ultimately get the excess bore water pressure to be hopefully zero, and then you get back a situation to where your clay goes back to your initial static water pressure. Now, that delta sigma 1 in equation 1 on page 3, right, is the increase of the vertical stress that you apply. But that increase of vertical stress, if everything remains, there are no losses, that is going to change into the change in pore water pressure, right? Change in excess pore water pressure that is being applied to the uh, to the soil and ultimately to the water. All right, the pore air pressure. Now, this is what we did last week. So that's the physics of it. You might just be stumped last week, okay, when I was mentioning to you about all this stuff, and then you might just look at the mathematics and you just say, oh, I don't, it's too much for me. Now, you do the homework, all right, whatever homework I give you, it becomes a problem to you if you don't understand. All right. And it is in my years of experience, this occurs because you don't apply the principles. And for a lot of you, maybe you like to memorize. So that is why in the last homework, in the bearing capacity, I asked you to do all the methods, understand all the things, don't just look at one method and then, and memorize that, because it will be a problem to you. Yeah. Okay. So now, a better estimate, of course, if you can get, the secondary consolidation, sorry, not the secondary consolidation, the secondary settlement, which is rho sub S. So if you can get all three, that would be great. Now, rho sub I, because of the elasticity, all right, you apply stress, you get a strain. Rho consolidation, because of the presence of water in this thing in clay, all right, and excess for water pressure, all right, and you get this phenomenon consolidation. And if there is a dissipation of the excess for water pressure, you therefore get the consolidation settlement. Secondary settlement, I said to you, is more because of the yielding. And if I am looking at my watch here, if I put a load here, I load to this wrist here, and I leave it for, I don't know, 20 million years, all right? And assuming that everything else all are okay, except for this wristwatch, all right? All right, it doesn't get rusty or anything. I believe that in 20 million years, this wrist, all right, would have yielded, and, right, this wrist would have been extended. So I hope that gives you an indication of what secondary settlement is all about. Now, in most circumstances, all right, we, in at least in a few of the examples you will see later, we don't even bother to calculate this secondary settlement, all right, unless it is given to you. Then, if data is given to you, then probably you have to include it. All right, so if you have been you had the time to look up consolidation, right? Remind yourself, since last Friday, I always impress upon my student, you should, right, always look up on those things which you forget, because it is a building block, so that it's easier for you to understand what the next topic is all about. So at any time t, at any time t, the equation number 3 will say to you, right, the settlement at any time t is going to be the immediate settlement. You will note that when the immediate settlement is because of the elasticity. You put a load, it has its immediate settlement. If you put it, say, in sand, right, you apply a load on sand, then you will only have immediate settlement, elastic settlement. All right. The issue is then just to find the stresses and then calculate the settlement. And you did that with me in soil mechanics 1 on that topic about stresses. All right. And then then you stop. That's it. You're done with sand. But if you have clay, you cannot stop. All right. You have the immediate settlement, elasticity, and then you will also have the consolidation settlement. So at any time t, the settlement, the total settlement, if you like, is going to be some percentage of the final consolidation. If the final consolidation is say 100 millimeter, and if I say in some time t is say, I don't know, 20 years, say, all right, okay, some 20 years, the consolidation settlement is 50% of 100. Okay, so you can say that U is the degree of settlement. Right? How much, what is the percentage of the total consolidation settlement that you would get, all right, at any time. Now, if you look at that figure 14.2 again, all right, just to give you an idea, look at this figure 14.2, and let's say that we use that conventional odometer settlement. Let's say that the total final settlement is about 50. Let's say that the total final settlement would take some 20 years, all right, some 20 years to stabilize, all right. This is almost stabilized here, all right, 50 stabilized. So it takes about 20 years. So 10 years, you know, if 10 years after the application of the loan, that's like, what is it? So I'll take something like, this is 50, I'll take something like 25 so that I can, it's easy for me to calculate, right? So I'll have 50, this is about 50, say that's 20 years. So I want something that is 25, say, 25 is 50%, right? Of the total final consolidation. So how many years do you get? Right to me, guys, otherwise I think you're asleep or you can't follow me. 25 millimeter, right? Out of 50, that would be... no, I mean, write to me lah. Send a message to everyone here. Don't talk to me, just send a message. Myra ni asyik repeat je, tidur ke selalu. Mira. Apalah. Look, if I look at figure 14.2, right? Shasha Zuprina says about 6 years. Okay. Just let me repeat for Mira sekejap. Apa tu, Shasha? Okay. So, 20 years, I mean, about 20 years for 50 millimeter, kan? So if I want 50% of the total final settlement, that would be 25 millimeter. 25 millimeter would be how many years, Shasha says? I look at it, it's probably 0, 5, 10, maybe half of that. Maybe Shasha is, okay, 7 years. All right. Shakila says 7 years too. Razin says 7 years. About that lah, kan? All right. Anyway, you get the picture, yeah? So this gives you an indication, 50% of the total settlement. So when I look back, all right, when I look back on page 3, that equation 3, all right, that new degree of settlement, you have a rough idea. So if I say, you know, at any time t, the time t here you said is, tadi a few minutes ago you said 7 years. So I have that message, 7 years. So the total, the settlement at 50% of the consolidation, all right, 0.5 of rho sub c on the second term, all right, I know that it's going to take 7 years already, but the rho sub I, all right, for this one, I haven't calculated. All right, so I'm just trying to give you an idea of that question 3, what that degree of settlement means. Okay. All right, I'm moving on. Page 4. Okay. What time is it now? I probably will take longer than what I anticipated today because of all that. Okay, 3:15 p.m. All right, Fazli says 3:15 p.m. Okay, no, I was just thinking that I might take a little bit more time than usual because, you know, I think I lost 45 minutes playing around with the LAN and all of that, like. I think probably that in future, if something that that is almost guaranteed is using the phone, it looks like, I don't know why. Right? I'm using this home Wi-Fi on the phone anyway. I don't know why it's you know, this is more stable, right? This is on home Wi-Fi and this is stable. I have no interruption so far. Can anyone explain to me what is happening? Why this is stable? And when I use the LAN, the LAN cable, it is not stable. I'm just taking a 5-10 minutes break before I move on. Arman, any idea? No? Your laptop is slow, sir. Good. Maybe I have to buy a new laptop, right? Sir, buy a new laptop. Nur Hafizi. Moa say maybe BC of your SIM company. What is BC? Not bearing capacity of your SIM company. Nur Iza say yes. Buy for me also, sir. Mana nak beli my duit dah? Orang dah pencen dah. Abby says, ayo Moaz. BC means because. Oh, okay, sorry.
Hello.
Buy MacBooks. I'm not into MacBook, Razin. I'm not into Mac. I'm into, I don't know what, you know. The other day I went to the shops when I was trying to fix this,
Salam.
what the heck do we call this? The, you know, the day when I could not read the Wi-Fi, all right? So they gave me this adapter, whatever it's called, this auto install adapter, right? 50 ringgit stuff. So I was looking at some of the laptop as well. Asus, I think it's probably okay, no?
Lepas tu pergi dekat rak buku tu.
Anyone have any idea? Not Acer, but this one.
Rak buku.
I'm just taking like 5 minutes break. This one. Benda ni.
Meja tu, meja.
Asus, ASUS. Saya pakai Asus laptop IR.
Belah sana.
Is it fast, Mira?
Bukan.
Asus also good.
Rak buku. Lepas tu ambil buku
Okay.
warna.
Alright. Fine. Maybe I buy another one. Maybe if I want to use it on a laptop. But right now, right, this phone is good enough for you guys, right?
Biru
No?
satu.
Dell, sir, Dell. Okay, fine. I don't know. Anyway,
Lepas tu
all right. ABC says it's good enough. Okay, Farina says okay, fine.
tak belah kiri. Buku geotek.
Okay, at some point also, I need to like, I don't know whether this is going to affect the my working situation in the sense that, okay, at some point I would like to also download the WhatsApp, all right, on the laptop. Okay, so what's your Parashasha has already tried to has actually
Buku
wanted to help me, but I'm just being slow about it, right? So because I think at some point in time I need to if that final exam is going to occur online and all of that, I need to like, you know, send stuff and all of that PDF and blah blah blah. So probably
dekat meja.
I need to have the WhatsApp on this laptop. If the WhatsApp on this laptop is also slow, then I think it become critical at that point in time for me to buy a new laptop. All right. In the interim, I'm just like putting things into my head.
Atas.
The
Lepas tu
other thing is that, yeah, I told you about this, about going into the faculty. It's pretty tough, right? Last week I mentioned to you about all this letter business and all of that. It appears that, you know, you can try your luck.
coklat.
You can try your luck.
Lepas tu
You can also use website WhatsApp.
cuba buka yang page warna tu yang
Sekarang pun okay je. Okay lah.
tu.
You can also use website WhatsApp. Yeah, I know Noriza, but you know,
Kosong
I think what's her name? Shasha actually told me that if you are going to download, you need the Wi-Fi. The laptop needs to have a Wi-Fi. The phone also need to have a Wi-Fi. And then sometimes I'm too tired to think, right? uh, okay. All right. Nanti. So anyway, that is on my list of things. And then faculty is difficult for people to come and whatnot. All right. You need a letter and blah blah blah. But if you want to try your luck just to get into the faculty, maybe the security guard won't be so strict. I might try that. Uh, that at some point in time. Yeah, Shahirman, it's okay. I have Shasha and I have also apa tu? What's her name again? That's from last week. I forgot now. I'm too tired sometimes because my brain is thinking of so many things, right?
Yang
Mimi,
sebelah
whatever her name is, Shamimi.
yang dekat meja tu kan.
Sorry, Shamimi, lupa. Okay, now break is over. Let me now go over this now. So, immediate settlement, all right, consolidation settlement. So now we are on the next page. We're talking about all this immediate settlement. Now the issue about immediate settlement is just what chart to use, what formula to use, what table to use. Why is it just table and chart and not so much on the theory? Because these are equations which people have produced for years. All right, they have produced for years and they have given you the charts and tables and blah blah blah. All right, so that's why. Um, that's why just tables and charts. So I'm going to quickly move on these things, right? Plus the fact that the fact that I've actually spoken about all of this previously to you. Now this is to do with the chapter in Craig's All Mechanic, right? That chapter on the stresses. All right. Just to remind you again on all those things, right? I have actually marked it down, right? Stresses from elastic theory, all right? With all of this, remember last week I showed to you all this business and onion bulbs and whatnot, and we went through all of this, right? In soil mechanics 1, all right? This is new mark start. So if you have forgotten, you have to really look into it. And I would really remind you again that example on page 173, which is to do with that Adams chart. All right, just sort of remind you, sir. That's what I meant by principle of superposition, where some of the areas are not the same. So don't go around trying to memorize only 4. All right, 4 times whatever I sub R and everything, because I keep getting that sort of thing from my students, right? After me having saying this to you. Okay, Abby says yes. Shamimi, all right, you're crying. I wouldn't cry, Shamimi. You know why? Because I keep forgetting. I can even sometimes forget to put on my shoes. So, all right, because when I'm thinking of too many things, and I forget. All right. Okay. All right. So you look at that equation on page, what do you call this? It's on page 4. Yeah, immediate settlement. You just apply elastic theory, like I said. And then there is this equation which is given to you, Q multiplied by B. Then you have that Poisson ratio. And then you have that Poisson ratio. You see, I forget your name, Shamimi, but sometimes so many things in my head, but I didn't forget that maybe we can have coffee with Shasha and all of that, right? Anyway, you see that equation, all right? QB1 minus Poisson ratio, then you have this I sub P over E. Now, the moment you see E, right, which is a modulus of elasticity, right, then you know that it is something to do with elastic theory. Okay, so IP is just the appropriate influence coefficient, and B is the width. Q is the pressure applied by fitting to the foundation soil, whatever pressure you apply, okay, or whatever stresses. Now, for most clay, right, most clay, and then if it's fully saturated, like I said, that if we just apply our equation to saturated situation in clay, which is what we normally do, then the Poisson ratio is going to be 0.5. Okay, so the issue that we don't know in relation to that equation on page 4, right, is just the I sub P. Everything else is just a product of what you apply. Q is what you gain, right? D is the width of your footing or foundation or whatever. Modulus of elasticity is what you normally get from a material. Poisson ratio, okay. If it is clay saturated, then it is 0.5. So I sub P, you look at that table 14.1, 14.2, and 14.3. All right. For table 14.1 is on page.
buku math ada? Buku math ada buku math.
It's on page. I don't know what page it is here because in this set of notes it doesn't have a page.
Yang
All right.
chalk yang
Uh,
yang besar.
this on what page? But if you look at this page here,
Sekali dengan dia punya tam.
in this set of notes, okay. Yuan says page 14.14. Imran also says 14.14. Okay. All right. Okay. Now I have 55 people. Who is the guy? Two more guys are missing here. Huh?
Satu je.
I don't know who is missing. Always missing. I'm supposed to have 58 people, right? Where is my attendance list?
Dah. Dah dapat?
Yeah, I'm supposed to have 58 people, guys. I keep having 3 people missing in my class.
Terima kasih.
Those of us who are missing, make sure you don't miss your class on the day I ask for the homework. Then it becomes a problem. All right. So anyway, you have to take the I sub P values from table 14.1, 14.2, and 14.3. Now, 14.1, you guys said to me is on 14.14, but it's available even in this set of notes, right? Otherwise, you're just going to like look in chapter 14 and find it. Okay, chapter 14 and find it. Now, Imran and Yuan has looked it up and they said that it is on page 14.14. Okay. I have here also on table 14.3 and table 14.2. All right, but if I were to look at that table 14.1, all it says in there is the influence factors for settlement of footing on the surface of a semi-infinite elastic solid. Length of footing equal to L, width of footing equals to B, then you have all of these things in there, right? And now whether it is rigid, flexible, now you want it to be at the center, corner, or the average value. All right, it's up to you. Because sometimes you try to find the settlement at the corner rather than at the center. All right. It depends on how and what you're going to analyze it for. Okay. So that 14.1 is the semi-infinite elastic solid. Now table 14.1, 14.2, and 14.3, they are all just I sub P for different situations that is being applied. Okay, so L over B, D over B. Now, which is why I'm saying, if you have forgotten about all of this, there's nothing much I can say, except that you might just want to have a look back at that chapter on the stresses and strain that I referred to you earlier. Okay, so if you can find the stresses, and then you have this influence factor, you see that the influence factor are there because, for all situations, when you use charts and curves and chart, curves, and tables, they are usually you have some influence factor to multiply the stresses that you apply. So it's a pretty much straightforward thing. Well, otherwise we'll just see the examples later on. Okay, so Moving on. Now, in figure 14.18, it is the settlement factors for corner of the uniformly loaded rectangular area on an elastic layer underlain by a rigid base. Then principle of superposition is applicable. All right, so now you have another situation, all right? Given your situation of whatever field problem that we have, then we just, look at this table and we say, okay, this looks like what I have in the field. So now I need to know the values that is applicable, all right, and stick in those values, okay? Now, when they say principle of superposition, remember a few minutes ago, I said 4 times, okay? So if I have, look at this box here. If I put in the center here, I divide it into 4. All right, each of those would have a corner each of this area would have a corner. When I put it all back, all right, they become 4 times the corner. All right, that is because the area that I had divided is the same, so it's 4 times. Otherwise, I said to you last week, calculate for one area, find the influence factor, find the settlement. Calculate another one, find the same one. Because, why am I saying this again to you? Because there are people in this class and in any of my classes who keep saying themselves, I memorized the 4. The 4 because the area is the same. 4 same area. All right, if I apply the same stresses on the 4 areas, so I don't need to calculate 4 times. I can just, no need to calculate 1, 2, 3, 4. I need to calculate, right? So I just multiply by 4. It's like, I have 10 cents in my pocket and I have 4 times of the 10 cents. So how many cents do I have? 40 cents. How do I get that? 4 times 10. If on the other hand, I take all those coins and I calculate 10 cents, 20 cents, 30 cents, 40 cents. Do I get the same answer? Yes. All right. 10 cents, 20 cents, 30 cents, 40 cents. When I calculate them singly, I base it on a principle. All right. Unless I know about this principle because they are the same, all right, then it is easy for me to say, okay, 4 times 10 equals to 40. All right. So, again, be careful. Now, moving on. Okay, so that is the principle of superposition I was trying to explain. So now I'm on page 5. All right. So again, at any point in time, we want to find the immediate settlement and the consolidation settlement. Now, here's where I'm getting to Skempton-Barham. All right. And all this while I said to you, we have this odometer test. And we are not happy with this odometer test. Okay. Why are we not happy? It's not so good when it comes to predicting the values of settlement. If we can improve it, we try to improve it. So as in figure 14.2, I showed to you that, Skempton-Barham is better, a little bit better than the odometer method, the conventional method. So now, remember I said to you earlier on that the consolidation settlement, now I'm on page 5, yeah? The consolidation settlement is equal to 0 to Z, Z being the depth of the clay layer, M sub V, if we assume that all of it is consistent with the depth, okay? Then we have delta sigma 1 earlier on, all right, on page 3 just now. We have delta sigma 1. And then we multiply by the thickness of the clay layer. Now, I said to you at that point in time when we were on page 3, I said to you that if I have all the stresses and then if I transfer it to the water, all right, the water in the saturated clay, and there are no losses, then I will have some excess static pore water pressure. Excess, that delta there, yeah, the delta U, that is the excess value of the pore water pressure, meaning the pore water pressure above and beyond the original static pressure. Now, and I said to you that if I can dissipate this, first I said to you that I need to transfer that all that stresses, all right, all that stresses which I load on the soil, then it is being changed into pore water pressure, all right, in the voids and pores of the clay, all right, and nothing is lost, all right. So if I allow that excess pore water pressure to dissipate, meaning that there is drainage, right? I used to show it to you that way, all right. Then it comes back to my original cheek situation, which is my original static pore water pressure. So the question then, what is this pore water pressure? How does the load you apply, all right, the load you apply at the top or at the surface or wherever you apply this load, all right, the stress, and then how is it being transferred to the pore water pressure, and how to calculate this excess pore water pressure? So you see that the equation is given by delta U. This excess pore water pressure is equal to B multiplied by delta sigma 3. Sigma 3 is the horizontal stresses, the lateral stresses, all right, and delta is the excess sigma 3. Originally, you might have a lateral stress, all right? Remind yourself there is an element of soil in the ground, and then you have sigma 3 and you have sigma 1, all right? This is stuff you learned in year 1, I think, in your strength of materials class or whatever, all right? And then plus the difference between the excess, all right, the increment of the vertical stress, sigma 1, and the increment in the lateral stress, sigma 3. I think if you did soil mechanics 2, I think Dr. Nick explained to you again all of these things, right? Delta sigma 1 minus delta sigma 3 is what is referred to as deviatoric stress, all right? This is to do with shear strength of soil. I did a bit of it in soil mechanics 1, but I think because there is a transition of the curriculum that it was repeated to you again, that course, that topic on shear strength. Okay, and then this thing called B is the Skeleton pore pressure parameter, yeah, determined through lab test, and the B is being explained is obtained to you through a triaxial test. Yeah, I recall that when I did soil mechanics 1 with you, I actually drew the triaxial cell, and then at that point in time, I actually hoped that you would be given a demonstration when you get to soil mechanics 2 on the triaxial cell. However, it appears that didn't occur. All right, so that's a loss to you in a sense. Many years ago, we would have done it. I don't know. We have all the newer lecturers. I don't know. They probably couldn't find the time to do it. Anyway, I'm trying to look for the picture of triaxial cell to remind you. I don't have to do this, but I try all the time to remind you that, if you forget your stuff from previously, it becomes harder for you to, but, maybe you can, maybe you can try to find some time to just, remind yourself what these things are all about. So if I'm to look at page 114, okay, I'm on page 107. Remember, I drew this. Well, for some of you, some of the others, they are not. They didn't do soil mechanics 1 with me. All right. Here's the triaxial cell. Now, why am I trying to relate this triaxial cell to that B value? The B value is obtained when you apply all this lateral stresses and these vertical stresses, and you can get that B value. So when they say Scampton pore pressure parameter determined through lab test, they are using this triaxial cell on page 107. Okay? All right. So if the soil is fully saturated, which is the case of the clay usually, then the B value is equal to 1, and then you get all this delta U, which is the change in pore water pressure. Now, if I substitute that change in pore water pressure in the original equation, I get that M sub B multiplied by this long-winded parameter. In the end, you see there, right, on page 5. Right, on page 5 at the bottom here, you have this new multiplied by rho odometer. You recall that when I was trying to talk about this Scampton-Barham method, I said that Scampton-Barham, right, would be referring to the odometer test. And why would that be the case? Is because all of us are more familiar with the odometer, since also last Friday, we are able to calculate using odometer result. So he has derived this equation here, whereby find your row odometer, and if you do your site investigation and all you did was just take a sample, go to the lab, and then did odometer test, and you didn't do anything else because you forgot, or you are not so good at doing site investigation, whatever the reason. So now you have that sample of row odometer. So you can still find your concentration according to Scampton-Barham. They say by multiplying that row odometer with nu. All right. So you see just now on figure 14 point whatever, 14.2, I believe, in relation to the Waterloo Bridge, right? So if you had just done the odometer test and to find that total final settlement using Scampton-Barham, you just need to multiply that total final odometer test with this nu, and nu is given by this. Okay, fine. This looks so complicated. You say to yourself, I may have been, by the time I get to 50 or 40 or whatever, I've forgotten how to even differentiate and integrate. So you are an engineer by that time, and you might not be able to do that anymore. But don't worry, Scampton says and Barham says, I am going to give you a chart, all right, and charts and tables. So you see that table 14.4 is going to give you the value of alpha. I'm already on the next page, guys. I'm on page 6, right? Okay. Alpha is taken from table 14.4, and if I can get alpha, and A is just some parameter, not the Scampton's pore pressure parameter, but some other parameter that we obtain through the triaxial test. Okay, through that triaxial cell test, and the nu, which is nu multiplied by row odometer to find the consultation. Right, that nu is a function of, on the next page, on page 6, A plus alpha 1 minus A. So if I were to look at these two figure 14.9 and table 14.4, so I can get my nu then, right? Now our problem is, of course, to then how to use this, right? How to use this in finding the settlement. So right now I'm just spending a bit of time with you in relation to all these theories. And again, you need to have some indication of what these theories are about, so that it's much easier for you to do the analysis later on. Otherwise, people get confused, and they do all sorts of funny things. You see? So that's where the problem is usually in terms of soil mechanics. All right. I'm looking at this slide. Okay, not slide, the handout. All right, I have here on figure 14.19, on page 14.19, sorry. All right, the values of alpha in Scampton-Barham settlement analysis. H is the depth to rigid stratum. Okay, and then next page on figure 14.20, figure 14.20 is the values of the factor nu. All right, and you look here, here's the small small picture here. It says H is the depth from the surface to the bottom of the clay layer. All right, it's an impermeable layer beneath that. All right, and then you have B. So you have circular footing or straight footing, and then you can figure all of that out. Now, if I were to look at grade, all right, and see the same chart, Ein Petria says you can't see. What can you see? The picture or what? Figure 14.9. Figure 14.9 is on page 1420. Okay, Ein? Figure 14.9 is on page 14.20 and table 14.4 is on 14.19. If you look at page 1420, you will see that small picture, right, on the chart. Can you see it now, Ein? Hello, Ein? What do you mean, no, sir? Ha, ha, ha. I mean, I have this picture 14.20. Yeah, this page here, 1420. You have that? Page 1420. Okay. All right. Then you have this small little picture here. All right. Okay. Fine. All right. Okay. Now, I'm going to look it up. The same chart in Craig. Okay. And then what do they have? All right. Consolidation settlement, if they do. It should be on the consolidation theories on chapter 7. All right. Chapter 7. Okay. 7.4 is a settlement by the Scampton-Barron method on page 255. Okay. Right, all those things I explained on the triaxial cell. You notice that this on page 256 you have that you know, the A and B and the increase in lateral and vertical stresses. Okay, all right. Now, so on page 259, okay. On page 259 is the same, not the same, similar chart of figure 14.9, circular footing and straight footing. All right. Now in figure 14.9, you have only circular footing and straight footing. Right. Most of the time we have square footing, see, or rectangular footing. So how then? You know, in one of the examples in Craig's book, or sometime in the future when I will, inshallah, God willing, if I were to get to that example, they change the you know, you can still use the same chart, but you change your equivalent area. So you just make the circular footing equal to the square footing, say, all right? One is equal to pi d squared over 4. The other is equal to, you know, length times breadth. If it is a square, it's just b squared. And then you take that d, and then you find the equivalent d diameter. Okay. So, you know, because I get some people, they then ask me, you know, so you give circular, you know, the chart gives circular footing, I have square footing. What am I supposed to do? You know, go jump into the lake then. You know, so I'm warning you about all of these things. All right, if it is possible to do all of that. Now, again, on figure 14.9, the factor nu is equal to rho c over rho odometer. All right. So if I can get the nu multiplied by rho odometer, then I'll get the rho c. All right. Okay. All these ratios you need to put into your head, because I noticed that a lot of time I notice, you know, the thing is right in front of you, right? And the answer is right in front of you, but you just don't know what to do with it. Right? That explains That basically explained to me that you didn't bother to pay attention to all the, what is this chart about. So you need to do all of these things. Now, page 259 of Craig and figure 14.9 is not like any different in terms of the similarities, right? So it shouldn't be too much of a problem. Now, what about this table 14.4? Do they have any similarities? They don't, I assume. Huh? Okay, there is none there. There is A, but they haven't given the alpha. I thought they would have had a chart where alpha is also given. Anyway, we'll do the example at some point in time, and perhaps then we will look at it. All right. Okay, you see on page 258, he's also doing the same thing as our as what we are deriving. Right, guys. I'm already on that page, and then I'm on page what? Page 6, right? Okay, I'm on page 6, right? Table 14.4. Okay. Now, so if I were to use these two equations, 2 and 3, right? And then I'm going to make this comparison between observed values, right? And versus calculated values. Remember all this equation and this settlement formula is a prediction, all right? Prediction of what is going to happen to our design once it's being constructed. And it, in soil, there are many other methods which you probably won't be required to learn, but for now, these are the two methods that is required of you. Now, on page 6, it says that if I were to make this comparison of over-consolidated and normally consolidated clay, all right, on the settlement, and this is to be shown on the page on page 14.21. All right, 14.21. I better give you some time to get to 14.21. All right. Oof. Are you all already on page 14.21? Table 14.5, page 14.21. PZ says yes. Amirul says yes. Amirul Daniel. Is Amirul Daniel also Daniel? Saya selalu panggil Daniel ya. Betul. Yes, I am. Okay. Nice to know you're here, Daniel. Daniel, you are the one who brought down the what do we call it? That slide machine, yes? Yes, Daniel? I'm still here. Yes, the old school stuff. Good. That's what we're going to throw. We're going to throw all that stuff into the garbage bin at some point in time. Okay, now you guys are on page 14.21. You have that table, right? You see that table. What Scampton and Barham did was that separate the two types of clay. I explained to you last week what is normally consolidated clay and what is over consolidated clay. It's just the way the clay has been deposited over time. Okay, if you have normally consolidated clay, you have one layer being formed over another layer, right? So it's just all being stressed. If you have an element at the bottom, it is more stressed than the one at the top, right? So if you have all of that being formed with time, right? Then at some point in time, you said to yourself, okay, I'm going to do some excavation. All right, some excavation for whatever reason. It could be that you want to have a basement car park. All right, so you're going to remove some of that soil. If you remove some of that soil, the element of soil beneath that excavation. Once upon a time, it has so many soil column on top of itself. Now you remove some of it, all right? So it has less stress now, right? And all this while, the stresses that it has been on top of itself has been, for donkey years. Since I don't know when, when the dinosaur was there. This is in relation to normal processes. Okay, so now if you remove that excavation for whatever reason, it now have less stress acting on it. That is known as over consolidated. All right. So more stress or less stress. Okay. So the way you stress a material called clay, all right, also affects its compressibility. This is what Skepton is trying to say to you. But I mean, you would have already known that if you had reflected on stresses and strain when you did soil mechanics 1. All right. Now, you look at that table now, table 14.5, right? And you have in one column here the observed settlement, all right, and then you have the conventional method, which is the odometer method, which is also the one-dimensional method, all right, and then you have Scanton-Barron method next to it, all right. So if there is a ratio of the calculated value, which is using the conventional method using the formula row odometer, all right, and then the Scanton-Barron method using the formula new row odometer, and then you find the ratio, and then you get the average for the normal consolidation is 0.81, and then Scanton-Barron is 0.99. So in relation to calculated and observed values, 99% of the time using Scanton method is nearer to the observed value. If you use the one-dimensional method, it's only 81%. All right. Now, if you look at the over-consolidated clay, all right, you look at the average value is 1.25 and 0.99. So I'm quickly just referring to the table, and then I go back to my page 6. All right. Sorry about page 6 is. Okay. And you look there on page 6, it says, all right, calculated values for normally consolidated and over-consolidation clay. This comparison was made in table 14.5, and you find that for normally consolidated clay, on average, okay, better than the conventional method. The Scanton-Barron method is better. If I recall, it was 99%. But the ratio of calculated individual values to observed values showed scattered result. You see, you have individually the results, right, on that table show values that are, scattered values. It could be so much higher, it could be so much lower, right? And then, but on average, it's not too bad, right? But for the over-consolidation, so in other words, for normally consolidated clay, Scanton-Barron is saying that not too bad if you use the Scanton-Barron method. But for over-consolidated clay, you will notice that the prediction via the Scanton-Barron is weak. It's like 1.99 just now. And then the conventional method is, on average, it gets 25% more prediction. All right, 1.25 was the value, so 125% better prediction than the observed value. All right. So you find that for over-consolidated clay, Scanton-Barron method is not that great. After all the trouble, we try to improve the situation, all right, from a normally consolidated, from a one-dimensional method, we then move forward to the Scanton-Barron method. We find that in over-consolidated clay, the prediction is not that great still. Remember in figure 14.2, I said to you that, it's about 60, even though the observed value is about 90. You make some improvement, but not that great. And that prediction is not that great, especially in over-consolidated clay. And that's why you have to learn other methods, the Lamb stress path and Poulos and Davis method. The Lamb stress path is to do with stress path. You have been introduced to the stress path idea in soil mechanics 2, all right? And even in soil mechanics 1, I already mentioned it to you. And then the Poulos and Davis, we probably won't, I might be talking about it, but on the other hand, you won't be tested on it, all right? Now, what was I going to say about the stress path method? The stress path method is just to explain to you why all this prediction that we make is not that great. Okay. The time now is exactly 4 o'clock. I want to take, say, like 10 minutes break or 5 minutes break, drink some water or something, and then go through an example on how to stress this problem, how to solve an example to solve how to apply actually the formula. All right. Is that okay with you guys? Send a message to everyone here. Abby says yes. Moa say okay. Nur Akila, oh, alive. Ain Putri. 5 or 10 minutes. Take one fish. Take 10. Is Iskandar around today? Still absent. Yeah, I know, Fazdi, you need a break too. You need to go to the toilet maybe. Oh, today he's not absent. Right. Let me just remove myself for a while. Yeah. Get some water perhaps.
Ha 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 ha.
Pazli Tule, Pazli is writing HA45. What does that mean?
Ha 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 ha.
Ha 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 many times. Okay. Okay, Amy. Uh, I will also try to draw. So the first one is I have a 2 meter square rigid concrete footing on a surface, I assume. Yeah. Okay, because the footing is not being mentioned to be at any distance from the surface, so I'm going to assume that it is going to be on the surface. I may be wrong, guys, so don't follow me. You do your own thing. It's important that you draw something yourself, right? Then compare with what I have, because then it's easier for you to understand things.
Kawan saya pun dah
So, okay, are you done? At least for the first paragraph. All right, I'm just not going to put the properties. Maybe I'll put the properties here. Saturated clay.
With solid rock at depth 6 meter.
6. And you get A.5. Then you get E sub U. Okay, so I'm not yet. I've drawn the first paragraph and second paragraph. I've drawn into my schematic, right? So you should get something like that. Can you see this? Hello. Liana says yes. Amira says yes. Everybody says yes. Ayn says hello. Okay. All right. So you get something like that, right? About right? Okay. Now the third paragraph. The third paragraph say you're going to calculate odometer settlement by means of the 2:1 stress transmission approximation discussed in section 7.5. The calculation based upon 3 2-meter thick clay layers are tabulated below. I'm tired, guys. Okay, first focus on that 3 2-meter thick clay layer. So I want you to draw the 3 2-meter thick clay layer. All right, I have a vertical load being applied to my 6 meter. Then it says divide the thickness into 2-meter thick clay layer. Okay, so let's do that. Okay, that should be easy. So you should get that. Fazli kata 2, 2, 2. Right. So it should be something like this. See, I have 2, 2, 2. This is still the same clay. And I have solid rock at the bottom here. Okay. All right. Okay. All right. Now, it says the odometer settlement of the 2:1 stress transmission approximation. Now, discussed in section 7.5, you don't have that in with you, section 7.5. I want you to now take your break book, the book break, and then I want you to open to this page. It is not going to be the same thing, but it's like, you know, for you to understand what I'm trying to say. Right. I'm on page 345 and I'm looking at figure 8.23 and it's about piles. It's about piles, but you know, the picture is similar. Okay. Can you give me an indication that, okay, Amy says she's got it. Anyone else? Abby says yes. Okay. Now you see here. All right, I just show here. Okay, Fazli got okay. You see this? All right, it is piles. But what they are trying to say here, I'm jumping the gun a bit, all right? I'm bringing forward some of this knowledge. But what is important is for you to realize that they have two layers here. For example, in this one here, right? And then they have the pile on top of, you know, the pile cap, they have the pile. But you notice that they have this ratio of the stress transmission on the side, 1:4 and 1:2. Can you focus on that and tell me that you actually getting it? Akmal says yes, Fazli says yes, Amy says yes, Abby, okay, Ayn says yes. All right. Now, when they said, now I'm going back to to our example. When they say by means of the 2:1 stress transmission on that paragraph, they mean like that 1:2 on page 345. Okay, on page 345. So actually, 1 is the horizontal and 2 is the vertical. Okay. Are you guys clear? Okay, Fazli says okay. So can we draw that? Alright, can we draw? Akila pun cakap okay. So Ain Putitra kata clear. So can we draw that on our schematics? So I'm drawing it using dotted lines. So I'm just putting my triangular ratio, right? So 1:2. All right, 1 is the horizontal and 2 is the vertical, right? Not 2:1. Okay, so I should get something like that, maybe. I don't know whether I'm right. Okay, you guys have to tell me because I'm like half asleep already. I'm tired. Okay, clear tak clear? When Amy says okay, Hafizi says JSP, Jap sir. Shafiq says clear. All right. Okay. Now, fine. All right. So now I have this like this three layers, right, of the same thickness. This is the same thickness. What I'm trying to say to do now is trying to find for each of this small layer. I have 6 meters initially. I'm going to find the settlement in the first layer, the second layer, and the third layer. All right. So macam mana nak lukis tu? Tu tadi Ain ada dekat page 345 tu, 1:2 tu. I've already lukis this. I will put the dotted line here. Then I put ratio 1:2. Syafiq kata clear. Lepas tu I kata sir macam mana nak lukis tu. Can you see this or not? Kalau tak boleh kan saya hantarlah. I will send this to Shakila and perhaps she will send it to you all. Okay. Ain dapat tak? Okay sir, you send to Shakila. Itu later. Tapi sekarang ni you ni. Now you should follow what I'm doing ni. Itu later I will do, but okay. See, you draw this, fine. 1:2. Why is it so important for you to like do this? It's because, all right, my next step is to say to you, okay, look, there is this vertical load. There is this vertical load, right, can be changed to a stress, all right? So it's just a load divided by area, and then it's going to be transferred to the first layer, to the second layer, to the third layer. So as I get further away from the surface, my stress should be less, right? My stress should be less because I'm further away from the stress, right? Okay, now I want you now to focus on the middle layer of the first, the not the middle layer, the halfway of the first layer. In other words, my depth now is 1 meter from the surface. Okay. All right. So now I am going down. I'm going to put a symbol Z. See my symbol Z here? And I'm going down. Okay, Z is 1 meter. See, Z is 1 meter somewhere here. Okay. All right. Okay. So I'll put in my table Z meter 1 meter. Okay. See my table now Z 1.0 meter. All right. Okay. Are you guys okay? All right. Okay. Now, all right, at Z equals to 1 meter, using that 1:2 stress transmission, okay, I want you to tell me what the area is. What the width is at 1 meter depth. In other words, I'll go back here. See here, I have this putting on the surface. I have a width here, which I hadn't put in. So if I go back to my paragraph 1, it says 2 meters square. So I'm going to put there 2 by 2. 2 by 2 meter square. See now, I have square 2 by 2 meter. Can you see it? Nampak tak? Okay, Amy kata nampak, Skandar kata nampak, Liana kata nampak, Fazli pun says yes, Ain says nampak. Okay, now this is at the surface. Now Z is 1 meter. What is the width here? At 1 meter, width. And ratio 1:2. Yup, width. Liana says 2 meters. Iskandar says 4 meter. Imran says 0.5. 0.5 terbalik kot. See? What is the width? Be careful. Calculate carefully. Arman says 2.5. Maybe 3 meter now. I don't know. Are you sure now? Is it 3 meters? Yeah, ratio 1:2. 1 is vertical, 1 is horizontal and 2 is vertical. So, what is it? Hakim Karim kata 2.3. No way. 0.5, no way. 0.5 is not the total width, AB. The total width, here, at the top here is 2. So the top here is 2 meter. Okay, now 1 meter down, it has to be more than 2. Sure? 0.5 is wrong, Bazli. It has to be more than 2, isn't it? Now Iskandar says 4, Abby says 3, Razin says 3. Yeah. Sure now? Okay. All right. So that's where the important thing is. Maybe after this you discuss among yourself. So now, all right, I want to find the width. All right, at 1 meter. Why 1 meter? 1 meter is in between the surface here, 2 meter thickness. All right, I want to find the width. Now, at the surface, you see the surface here, all right, 280 divided by the area, it will give me the stress. All right, okay, 280 divides at surface. I'm just going to write here. Okay, 280 divided by 4, which gives me 70 kilonewton per meter square. Okay, kilopascal. Okay, kilopascal. That's as the surface. Okay. Now, at 1 meter, I'm going to find the width. All right. So it has to be, see, I have here 2 meters. Then I have to find out what this is. So it has to be more than 2 meters. So this is for every one horizontal is 2. So 1, I should have 0.5. So 2 plus 0.5 plus 0.5, I should have 3. Am I right? 3 meters. Right? Moa says 3 meters. I could be wrong. Okay. Now AB says yes. Moa says yes. You see? So I should have a width 3 meter. I'm going to put question mark. You're going to find out. All right. Now with that 3 meters, 3 times 3, right, 9, I can find the stress, like I find the stress here. Okay. So I should get the stress now. Why is it important for me to find the stress? Because the stress now is just the row odometer. Finally, in that column, row odometer is equal to m sub v, right, multiplied by the thickness multiplied by the increase in stress. Right? Look at this column. Look at the n column. M sub v multiplied by the thickness multiplied by the increase in stress. This increase of stress is going to be 280 divided by the area of this width that you find. That's delta sigma. The thickness is always 2 meters. 2 meters, 2 meters, 2 meters. All right? So m sub v is a constant. So that's where the problem is, to find this area, width and area. Okay? And then you will get all the settlement. So for the next, then do it for the next second layer. All right, second layer thickness here at 3 meters. There is 2 meter different. Okay, and then do the next one at 5 meters. All right. So then you repeat that whole process. So when you look at this example here, when they talk about this example, right? This example, and you have it 1 plus Z plus B, blah, 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 all of that. I don't want you to do this. I want you to understand the principle, because this mathematical way of doing this, right, doesn't give you the physics. All right. I understand what is being done here, but you don't understand. You see? So when you do it this way, You see, you have 1:2, right? This transmission, 1 vertical, 2 horizontal, and you find the area, right? The vertical divided by the area at the surface, and then now you find the width here, and then find the area, and then you have 280 divided by the area, it will give you the stress. And then the increment of stress here as well, and the increment of stress, because the area keep increasing because of this 1:2, all right? 1:2, right? Okay, 1:2 transmission. So the stress will be decreasing, right? Will be decreasing as you go away. So redo this table. Redo this table using what I explained to you. All right, what I explained to you. Okay, got it? Yes. Fazli say, oh, this concept seems like soil mechanic to settlement. Yes. All right. Okay. Now, so now that is the odometer. All right. 2:1 stress transmission. All right. Okay. I think actually, okay. Never mind. All right. So now from table 14.4. Okay. The value of alpha for a circular footing may be used for the square footing in this problem. Remember when I said to you earlier that if I have a circular footing and then, sorry, in the chart, you have circular footing, but now you have this square footing. So you use the square footing in this problem, all right? So if the depth Z over B is equal to 6/2, then it's equal to 3, and alpha is equal to 0.29. All right. And then U is equal to, then you just stick in there to get the U, mu, and then you will get the consolidation, which is rho sub C. I'm already on the next page, figure 14.23. So you get the consolidation is U multiplied by the odometer. Okay. So that's just the consolidation settlement. Everything else is given. All right. The difficult part here is just the how you find that stress increment. Okay. And then from table 14.4, you can use for a circular fitting. You can change it into a square fitting if you want. All right. You may want to, you know, when you're using that table 14.4, right? I'm going to write here, I have a square footing, make it the same, equivalent to a circular footing. Right? So this is given, square footing B squared. The circular footing is pi d squared over 4. All right? So you see here at the bottom here, so you might want to be more mathematical and you say that, look, you know, the area that is given square footing, then this is pi d squared upon 4. All right. So the diameter is the equivalent diameter for the square footing. Okay. All right. I hope I'm not losing you guys. So I'm on page 14.23. I am done with the consolidation settlement. All right. Now, find the immediate settlement. The immediate settlement use the equation whereby the solid rock is at the bottom. All right, solid rock is but they use it impermeable or something like that. So you can just use that equation, and then everything else is given. All right, the Poisson ratio is given. Then from table 14.3, you can get H over B is equal to 3 and L over B equals to 1. You find the influence ratio, you stick it in there. Now you get your immediate settlement. All right, then total final settlement, you just add the consolidation settlement to the immediate settlement. Okay, now in on page 14.23, right, the total final settlement should be 0.057, all right, plus 0.037, not multiply there. Can you see that? It's not multiplied. And and then you get that 0.094. Hello? Are you awake? Yes, AB. Yeah, you understand what I'm saying, right? So perhaps, okay, right, fine. Guys, that's where I want to stop, right? For the, ooh, for this, for today, right? This example is on page 14.22. Do you still want this page that I draw, that I just drew? You need to? Yeah. Ini yang those people yang one ni, yang dah ni, I think I think you guys, right, didn't do it. Okay, whatever it is, right? I may not write the right thing, but you better, discuss it among yourself. Okay, all right. So I'll just take a picture right now, and then I'll just, so that I don't forget, and then I will, inshallah, God willing, I'll just. Ni apa benda Fazli cakap, kata yang minggu lepas punya ada tak sir? What the heck is that? I don't know what you say. Can someone help me? What is he saying? I don't know what Fazli is saying now. Right? See, even Hafizi is saying entahlah. Yang MSE online first class tu apa tu? Siapa pun pening. Drawing yang Sir lukis minggu lepas ke Fazli? 2 minggu lepas kot. I've already given it to Shakila, and I think Shakila have actually circulated it amongst you people, no? Kata Sir nak bagi kat Shakila, tak bagi pun dah bagi. Tak lah, dia tak tengok kot. Shakila dah pening. No, last week I gave to Shakila the picture. All right, I think Shakila reminded me that she wanted the picture, so I actually drew up and I sent it to her. Then I don't know what else I'm supposed to do. And then of course I did only for 18.1 and the example on that page 14 point something. And then example 8.2 and 8.3, I just got tired of it. I say you can do it yourself now. Tak apalah Fazli, yang itu you tanyalah kat Shakila ke siapa, discuss among yourself ke kan. I think I don't know what picture. Now I want to take this photograph, tapi my phone is still there, so I will take after this inshallah, and I will give it to you lah, inshallah. Okay. So now what was I going to talk about dengan Shakila? I cannot remember now. What do I need to talk about? Okay, Shakila, can you on your mic and just explain to me what Dr. Azizi did in terms of that online assessment? You know, yang all the other guys, Arman explains. Why Arman? Okay, if you want Arman to explain, fine with me also. Guys, I just need to know what is happening in terms of this online assessment. I personally find that it's going to be difficult for you and for me, right? I don't know where they're going to do it, but and Razin, okay. But as it stands out now, I'm wearing. I'm not thinking of giving test 2 online, but I don't know whether that is possible to do it. Yeah, right. I have already given you that online general guidance. I think Shakila has circulated maybe today. I don't know. All right, I haven't managed to read that. Okay. So can somebody explain on the mic and just explain to me? I just want to have a rough idea. Was that online assessment by Dr. Azizi? Did she put it on Putra Blast? I hate using Putra Blast, guys. Iskandar said yes.
Hello, sir.
Iskandar, okay.
Yeah, so what Dr. Azizi did is she posted the question on Putra Blast. So we download the document
Mhm.
and we do it within the time given. We uh we submit it on Putra Blast. So
Okay.
that was it.
All right. Let me get this straight. Let me get this right again. Yeah, Arman. Okay. She posted it all on Putra Blast. The question, right?
Yes.
She posted it at the moment you were about to start, or she posted it earlier and all of that.
A few minutes before the test starts.
Okay. Few minutes before. I need to write this down because you see what happens to me is that as Shakila probably have realized it as well. Sometimes I have too many things in my head and I say, what did I talk with Arman about? Okay. So I'll just write it down for a few minutes before test. All right. And then you people downloaded it, right?
Yeah.
Downloaded it. Yeah. And then so in essence that it wasn't like you just basically have the whole exam, the whole test question in front of you, right?
Yeah.
Yeah. And then were there any choices with respect to the test?
Choices as in
As in, there are 4 questions and you need only to answer 3 questions, that kind of thing.
no, we answered all the questions.
You need to answer all the questions. Yeah, I understand why you need to answer all the questions. Yeah. Okay. All right. Download it, answer all the questions, and then you need to do your stuff, right? And then you have
Yeah.
to send it, and then you have to upload it
Ye-
into Putra Blast, right?
Yes. She gave us about 15 minutes to
Right.
scan and upload, if I were mistaken.
Okay. 15 minutes to scan and upload, right?
Yeah.
So, this business of scanning, is that like a problem to people or not? I mean, for me, right? For me, it's a problem, Guys, don't write anything yet because I'm not focusing on you, right? I'm just focusing on what Arman is saying. If you write, then I don't know what you're talking about, and I'm like, okay, fine, then I'll miss out on all these things, right? Okay. Nanti satu-satu. Okay, so I'm just trying to get it uploaded Putra Blast 15 minutes. My question would be like, uh, Shasha, Zukrina, Arman will be our representative. Representative apa? Shakila dah give up dah. No, uploaded Putra Blast 15 minutes and then you have to scan and then and upload it. Now, you see, I'm trying to gauge all of these things, right? This is the reason why I am a bit, reticent. I mean, not that keen to do this test too, this way. Was there, Arman, any was there any invigilation type of thing? Was the camera on and all of that?
Um, for Dr. Azizi's test, there wasn't, but for for hydrology, for Dr. Balkis, she did ask us to turn on our webcam, our camera.
Okay.
So I guess it is optional if you want if you want us to turn on our camera.
Mm. Now, but you turn on the camera, then I'll just pick at random who is doing what, lah. Is that
Yeah.
how the process is going to be going?
Essentially, if the camera is turned on, that means you are indicating that the task is not open task, because meaning you will be monitoring us. So that means we cannot refer to our books. But if it's an open task, so you don't need to monitor us, then we don't have to turn on our camera.
Um, uh, yeah. I'm like struggling with these guys, right? You know, I'm thinking that maybe I won't do it for test, right? And then, but maybe for the test, I just give you some of the, like I already said to you, that I may be picking up one or two questions or whatever, right? But it's just that you don't know which question, right? Or I don't know, maybe just moving from there. I honestly don't know, right? But as it stands, I think maybe Shakila have sent it this morning. I sent it to Shakila that the final exam, right? It appears is going to be online. All right, it's going to be online. Only that what is it? It's the SOP, the standard operating procedure, has not been specified. So I'm thinking in advance all of this thing, right? Okay. I mean, the reason why I am asking about all those scanning and all of that, right? Because for some people, they may not have it. Susah, very difficult. For me, for example, I don't have scanner at home, you know?
Yeah, scanning,
Mm.
it takes time if you have to scan multiple pages.
Yes. So this is what you're going to like put up with if we have to go through the final exam, right? Because it appears that the final exam may be unavoidable to do online. I'm not too happy about it, but then that's the way things are. So that's why I'm like, yeah. Now, if it is like final exam, it cannot be anymore open book as such, is it? Unless the
Yeah,
questions are made very difficult, because open book generally are very difficult question.
Oh my god.
Do you realize that?
yes,
Ah, ni Iza baru cakap oh my god and all of that. Yes, kalau open book it's very difficult because you can open the book, so the questions are not straightforward anymore. So unless there is a closed book exam, then you switch on the camera, which I don't know how you actually monitor all of these things. All right, then only it will be your standard everyday question lah. Right?
yeah,
You see. So the other thing is I don't know, guys. Talk to me, right? Because I'm having a hard time here. It is impossible to monitor 50 plus students in one time. Yeah, I know, Iskandar. So, open book lah. Kalau open book, then don't cry lah. Anyway, if I don't do test two, I just take it as part of coursework, right? Then you already have pretty good marks, isn't it? Shasha, there's no way open book give us more time. I mean, yeah, I used to sit open book virtual mana boleh. How can you do it like I mean, final exam, the way I see it right now, final exam, they say online assessment. I think they are going to say, such and such a date, you have to turn up for your final exam, just like normal. Although they haven't said anything about it. You see? So if it is, you know, you see, Iskandar, you said similar to test one. You know, test one, you guys are late. You know, it will be harder than test one. And it will be like, you know, because if it is final exam, you know, I may only be able to give you 3 days. Paling lama. Why 3 days for only because, you know, I have to give in the answer script to the registrar and all of that. And at the moment, I'm having problems trying to even gain access to the ESMP. Shamimi, you're saying if it is a coursework, but final exam is online assessment. So what on earth are you talking about? You see? This is why I'm having a conversation with you guys right now. Nak change final with assignment or something like that. Who, mana nak boleh? Kalau if they say online assignment. You see? That is why I'm thinking that, you know, I shouldn't like do any online test for test 2. All right, test 2 test 2 for you know, online and all that. I'll just pick up some questions and that's it lah, kan? But for final, I'm warning you, things may not be the way we want it to be. All right, so you know, you might not get your A then. You see? All right. Okay, guys. You know, by the way, Arman, this apa tu, was Aziz's question very straightforward?
Tak.
Not really.
Not
There are
really.
some.
Was it like you have to like design stuff and then make assumption?
If I were mistaken, there were some assumptions that you need to make, and you need to state in your working.
Okay. So it's pretty hard then. Was it 2 hours?
1 hour and a half, I think.
1.5 hour. How many questions? 3 times. AB says not enough time. You see, that business of not enough time is like quality control. You see, you realize that that question too. You don't have enough time because it's also a quality control. You see, it's like you either know how to do it or you take some time. You know, right? And 1.5 hour. You know. I mean, Fazli says 3 questions. Some people say 1.5 hour, 2 questions. Apa ni? Dalam what Syamimi, I don't understand what you're saying to me. Dalam teaching plan yang saya bagi tadi itu macam boleh buat. What on earth are you saying? When did I give that teaching plan? Arman, do you understand what Syamimi is trying to explain to me?
I think she's referring to the guideline, the SOP given.
Oh, that guideline yang Nabila bagi itu.
Yeah.
Yang itu, you see that one is the guideline on online assessment in relation to the semester. If you notice, I also sent via Shakila that she said that final exam is online assessment SOP is not defined yet. Kan ada, right? Yes. That's what I'm referring to. I was afraid when I give both of that to you that you're gonna get confused as well. Right? So yang online assessment, yang guideline tu, the guideline with the PDF file, I believe that was for like whether I do test 2 or not online, I can get away with it, right? That's what I'm thinking. I didn't bother to read it. I haven't managed to read it. Okay. So that's why I'm thinking like, if I don't do it, so I'll probably be able to do it. So, but final exam, given that the SOP is still not given out, so it could well be that it would be a situation like you have like Dr. Aziz's situation or Dr. Balki's situation. You see, I'm afraid of that. You know, that's why I'm thinking. Kalau kena buat tu, then I think I have to write the questions and then I have to submit for what? For wetting, for moderation. I know some lecturers have already started doing it. So, any thoughts? Now dah senyap pula. By the way, I think that from in future we just have to use this phone, right? Just for teaching purposes. I think there's no point anymore for me to like try anything else. Maybe that if I take the dongle and stick it into the laptop, that wouldn't make anything better, right, Arman?
Probably not because
It's a laptop.
the laptop is slow.
Yeah, because I think the laptop is a bit old. I think so. So I think yes, use phone better. Might not need tripod as well. Shasha Zukrina says that. Yeah, because now I can put it on top of the laptop. Okay. Aduh. Syamimi, what is in that PDF file tu? Dalam teaching plan yang saya bagi tu macam boleh buat. Yes, tu apa benda dalam tu. I haven't read it. Now she's asleep. See, now I have 48 people now. So some of us have gone home. So, okay, I think any other question? Thank you, Arman. I think the general picture, I got it anyway. Kalau if I still need some more convincing or something, I'll just ask I'll just ask Shakila, and perhaps she can explain to me or anything. Do you have any questions on today's lecture? Anything else I can help? No? No, yeah? So, okay, before I forget, I will, no, Amy says thank you. Oh, yeah, by the way, I was reading some, what is it? Some report somewhere, right? Just to explain to you, right?